Hi, my name is Mithun. I am a principal in quality engineer here at ConnectWise, and I'll be talking about resiliency today. So, what exactly is resilience? Now, the Oxford Dictionary says that resilience means the capacity to recover quickly from difficulties or toughness, and the ability of a substance or object to spring back into shape or elasticity. That's a dictionary definition, obviously. So how do we reconcile all of this to a software paradigm, right? So what happens when something goes down in your system and something else is dependent on that? Obviously, the dependent thing loses a part of its ability to do something or to give you some information or something like that. What happens when something goes down and what how we react to it, how the system reacts to it, and what the blast radius is, and so on and so forth, is all a part of resiliency testing that we do over here, right? It has a lot of different kinds of meanings throughout software, the software paradigm, but overall it basically means if stuff goes wrong, what do we do, right? And resiliency testing is testing of that aspect of a system, of any system, be it a monolith or be it a microservices based architecture. But it has a lot of significance for the microservices based architecture, not so much for the monolith because nobody tests them anymore, I guess, or nobody makes them. Uh, it- but jokes apart, so let's delve a little deeply into what it looks like. Right. So this is a monolith system. If you look at this monolithic architecture, right, and what do we have? We basically have a UI, business logic, data access layer. These may be on different systems, but they act as the same part, right? Mostly, if you look at all of these legacy applications, they will be on the same system. All the UI, the data access layer, and the business logic. They may be clustered, they may not be clustered. That's a different thing, but overall, it is on the same system, right? And this DB over here will be on a separate system because that's how it has always been. So, what happens when this connection gets broken, right? The connection between the UI business data access layer and the DB. What will happen? What have we obviously seen, right? Till now. Till now, we have seen that if the DB does not exist for a system, the system basically starts giving off errors. It will be unusable, stuff will not work at all, right? And which is how it was meant to be. But can it be done gracefully or not? When the DB connection goes off, can we go ahead and tell the users that something is wrong? You may have seen a lot of systems if you try to access them, right? um, During peak hours or something like that, and you're not able to get a connection or you're not able to uh, do something over there, it basically tells you, okay, there's something wrong, please come back later, and so on. Not IRCTC. IRCTC is a different level. Um, but yeah, so something similar, right? So if you try to book a ticket on IRCTC during peak hours and something goes wrong, you're not told that, something is wrong. You just your money is deducted and you don't get the ticket, right? It will give you a message saying that okay, this went wrong and so on and so forth. But yeah, I digressed a bit. So so the point was, what do we do when a database connection gets cut, right? How the system behaves about it? Does it just keel over and die? Does it, crashes the server? Does it do something? Does it crash everything? Do people even have to go in and restart the server to get it back up and so on? So all of these are part of resiliency. So when I test for all of this, I will know that how the system behaves and so on. Now this is a very simple system and it only has one connection to the outside, right? Which is the database. It may have connections inside between the UI, business logic, and so on, but a monolith is a monolith. This is a very simple system. So you only have one single point of failure over here, or another point of failure might be the machine itself. So modeling for this is pretty easy. If you look at the So modeling for the resiliency test over here, it's just cutting off the database access and seeing what happens and how the application behaves for that. Now, that is about the monolith, right? So if I go into a microservices architecture, right, which is something like this, where you have the UI and it talks to multiple microservices, one, two, three, and those microservices have database connections. They may be talking to Kafka. This is a very simple diagram of that of the microservices architecture, but you get the point, right? And the microservice might be talking to another microservice. Uh, the database itself might be clustered, non-clustered. It might be on a different VPC somewhere in Amazon or somewhere, right? The microservice might itself have scalability. It may not have scalability. Uh, there might be X number of things going on, right? The architecture by itself is meant to be very flexible. So what happens when any of these things, any of these connections over here, they break? What happens to the user experience? What happens to the UI? What happens to the microservice itself? And how do we deal with those failures? That forms a part of resiliency testing, right? Dealing with failures and getting back up, basically, is what resiliency testing is all about. Throughout this, the plan is to make a series of videos, short videos about what resiliency testing is about and how we can automate it and so on, right? So this was just an explainer of what we are looking for. So yeah, so I have explained about microservices and monolith in terms of resiliency, right? But what exactly are we looking for, right? So I have this page on our conference, which basically talks about what our resiliency experiments are going to be and what we are going to focus on. So, keeping in mind that I talked about resiliency on a terms of application and infrastructure, right? So, basically, resiliency comes in two aspects. One is for the infrastructure itself, and the other one is for the application. What happens when an application errors out? The application might be application meaning a microservice, right? It can ether out for variety of reasons, and it can be called by multiple people as well, right? So multiple people meaning microservices. So what happens when application A has some errors and it cannot effectively answer to application B, which is dependent on it for information? At that point, what happens? Right? There are retries, there are cancellations, right? What happens when an application panics? Now, panic is a proper Golang thing, right? Where a nil dereference or something happens to it, and then it just restarts, right? Whether the developers have put in a recovery block over there or not put in a recovery block over there. So all of this testing is on the application level. Then the infrastructure level, where we basically have these nodes, we have pods in Kubernetes, we have uh, instances of Docker instances, right? What happens if the disk gets full? What happens if, let's say, your hardware basically fails, right? What happens if your network connection gets slow? What if there's a lot of jitter, latency, right? There are bandwidth issues that you have, right? Firewalls, a lot of things go wrong in our production environments. They can go wrong due to some mistake that somebody makes, due to just the nature of uh, how the cloud is, how infrastructure is, how the networking is, and so on, right? So all of these things, how do they impact our application? How do they impact our system? Is what resiliency testing is all about. And now, in order to um, take a look at all of these things, we have to start somewhere, right? So one of the ways to start somewhere is start modeling about what can go wrong with your system. So that has been described earlier as well. I'll describe it a little bit. Like modeling, for instance, uh, getting to know, okay, this is the major function of my system, right? Uh, let's say I'm from the ITSM world, so I'll talk about ticketing, right? So in my case, a ticket that has been submitted to us by the customer should always make it to us. right? And our systems are designed in that way. But what happens when something goes wrong? So my resiliency test will always be focused on figuring out whether a ticket that has been submitted always makes it to my end or not. Now that could be done via a combination of retries about pushing it to Kafka and so on, right? But that all depends on the architecture of our system. So I have to first go and understand what the architecture of my system is, what problems might come up that may be compounded by the architecture of my system, or that may be solved by the architecture of my system, right? And designing tests in such a way that basically I can prove that my system is resilient or it is not resilient. I'll come to it a little later why I have to prove it both ways. Uh, but that is what testing is about, right? In any case, so these were all the resiliency aspects that we have to take care of, infrastructure, application, and these are all the types of errors that we can introduce, right? Um, okay, so resiliency is also part of, so everybody must have heard of chaos testing as well, right? So resiliency comes one step before. Resiliency is about making sure that you can handle errors and you can get out of those errors. But and resiliency is always controlled. I will not push in 10 different things at one time and see if my system can actually handle it. That is chaos. And 10 different things at random times is true chaos. But with resiliency, it basically means we just introduce one error, we check what the system does to it, right? And how to do it. And we have complete control over the parameters of the test. In chaos, that's not the case. It should not be the case. That's another matter. Um, so there are some places where it may not be understood of why it happened, why it did not happen. So resiliency comes into that picture where you basically have enough things to determine what went wrong. Right? It's not only about verifying that a system is resilient in terms of, okay, this went down, so my system is okay because it gave the correct error. The other thing is, if something goes wrong and your system is not capable of handling it, did it log it properly? Did we have enough information to accurately verify that something or the other went wrong, or what exactly went wrong? Even that is part of the resilience, right? As the Oxford Dictionary said, right? The capacity to recover quickly from difficulties. So infrastructure issues will not always be permanent, right? They may happen for 5 minutes, they may happen for 10, they may happen for half an hour. You have to understand that what your system does in those situations. So in short, I'll say resiliency is about measuring the impact of issues that may come out, measuring, defending, and then defining basically what happens. Okay, so this is about resiliency. What we are doing over here to automate these kind of resiliency tests. So we do resiliency tests over here, and I think ITSM has a track record of having resiliency tests inbuilt, and a lot of architecture changes have happened in our project because of having these tests in there, right? Um, so we have been doing it, but we have been doing it manually because that's how you start, right? You do anything manually first, and then try to automate it. So this is an attempt to automate it. So what we have done is we have started using Chaos Toolkit, and in the next video, I'll basically go through the basics of what Chaos Toolkit is and how it is used. Now, the name Chaos may throw you off a bit. That chaos, not resiliency, but it's one on the same. It's just how you control it that goes off. So in short, I'll basically go through the Chaos Toolkit basics. I'll set up an execution environment, run a simple experiment and show it to you. Um, do a Docker resiliency test. I've mentioned it as Gremlin because I did a demo with Gremlin some 2 months back. And I have also done with Docker for Chaos Toolkit. So I'll explain that as well. Um, There's AWS Resiliency, basically the infrastructure level stuff that I was talking about, shutting down instances, restarting the instances, taking out whole AZs and so on. That can be done using the AWS plugin inside Chaos Toolkit. Dependency based resiliency. So I talked about microservices having dependencies between each other. How do we make sure that we compromise those dependencies between them and see what happens, right? Then you have network observability. So network goes down, your network slows down. What? How does it impact your application? How does it impact your performance and so on? The last one is observability. So that's basically so we have a lot of monitoring that goes on, right? So we have to make sure that monitoring catches all the problems in our system. So this is basically using Prometheus in an automated way to identify that our system monitoring is all up and running and problem free during injected resiliency issues. There's Kubernetes as well, but we don't actually use it very widely here. So Kubernetes is something that is there, but I have not planned for it. I'll basically be going through all of these in the coming videos, and yeah, maybe you'll hang around with me and learn a little bit, and I'll learn a little bit by know uh, going on about resiliency and so on. Okay, so thank you, and thank you for watching this, and maybe we'll meet again next time.